Hello guys, it is Research Series, and in this session I want to discuss how to measure if your dataset have a normal distribution or not. So, why normal distribution is very important. Normal distribution allows the researchers to use parametric tests which provide more information and are more accurate. But if your dataset has not a normal distribution, then you should use the non-parametric tests, which are not preferred over parametric tests. So let's begin. For example, assume I want to measure if this variable age has a normal distribution in my dataset or not. First, you must choose Analyze, then Descriptive Statistics, and then Explore. You have some options here, and the dependent list. The dependent list are the variables you want to measure their normal distribution. And I entered age here. You can also measure if some variables, not just one of them, have a normal distribution or not. For example, I can enter height also here, but I just now want to measure the normal distribution of age. And then there's a factor list here. And what is the factor list? The factor list is indeed the grouping in the selected variable. For example, assume you have 2, 3, or 4 groups of patients. For example, based on their gender or based on the drugs they are using, and you can measure the normal distribution of data in each group separately, but it is preferred to measure the normal distribution of data in a whole population. So I left it blank here, and here you have a very important option: plots. You must select histogram and select this one, normality plots with tests, and then continue. Okay, wait a few seconds and you have the results here. The first box here shows me that I have 23 participants and none of them is missing, and here are some descriptive information. For example, the median of my dataset, the variance, the minimum, maximum range, and interquartile range. And here is a very important result for us: skewness. Skewness means the deviation from the normal state, and if the skewness here, the number here, is between -1 to +1, then your dataset has a normal distribution. But if it is more than -1, it is out of the range between -1 and +1, then it has a non-normal distribution. It is not normally distributed. And this box is also very important. You have two tests here: Kolmogorov-Smirnov and Shapiro-Wilk test. The Kolmogorov-Smirnov is preferred over Shapiro-Wilk tests when your dataset includes more than 50 participants, but it is not a rule, and you can use both of them. If the significant value here and here are less than 0.05, then your dataset has not a normal distribution. But if it is equal or more than 0.05, then your dataset has a normal distribution. And here you have a histogram, and you can better visualize it by double clicking it, and a window like it will open, and you choose this option here, and a curved line will be added here. And if this curved line is similar a bell, and most of your data are distributed in the center, then you can conclude that you have a normal distribution. However, you must be sure that you don't have so many participants here and here. The existence of lots of outliers means that your dataset has not a normal distribution. And you have another plot here, the stem and leaf plot. And again, if your data is concentrated here in the center and the extremes are left alone, then you can conclude that you have a normal distribution. But you have 3 participants here and 2 participants here, and among 23 participants, 5 of them are in the extremes, and it is significant. And you can here observe the QQ plots. The QQ plot is a very important test to measure the normal distribution. If these dots here, here, and here, all of them are on the line or very near it, then you can conclude that your data has a normal distribution. And I can conclude my variable age has a normal distribution in this dataset. And the box plot test. The box plot can also measure the normal distribution of your dataset. If this line here, this line is the median, if it is located in the middle of the box and the arms here and here have the same lengths, then you can conclude that your dataset has a normal distribution. And but in my dataset for age, this line is not in the middle of the box. So I have some results in favor of normal distribution and some results that are not in favor of normal distribution. So how can I report it in my article? For reporting the normal distribution of your data, you must be optimistic. Why you must be optimistic? Because in the presence of a normal distribution, you can use the parametric tests, which are very useful and important for us. So you must be optimistic and consider if some of the tests are in favor of the normal distribution, then your dataset is normally distributed. So, also, you can report the significant or the significant value or p-value of the Shapiro-Wilk test or Kolmogorov-Smirnov test or the skewness amount here to prove that your dataset has a normal distribution. If you enjoyed this video, please don't forget to like, subscribe, and comment. We have also a scientific English editing service editing masters, which receives orders from authors who wish their manuscripts to be published in high-impact journals. If you wish the same, you can send your manuscript to this email address for language editing.